All right, Gen Chem kids, we are going to learn how to do chemical reactions and equations today and how to balance them. Okay, so chemical equations, here we go, chapter 8, chemical equations. In words, they describe the reactants and the products, but they are really long and time-consuming to write. So our reactants, let's start with that. They're the things that we start out with. These are our beginning items. They're the items that we start out with. And the products are what we have once the reaction is done. So these are the things that we end with. Okay, it's kind of like if I was in the kitchen and I was making some cookies, like my reactants would be flour and butter and sugar and probably chocolate chips and things like that. And then my product would be chocolate chip cookies. Okay? So if I wrote this out in words, could you imagine? Lead 2 nitrate and sodium chloride reacts to or makes or yields lead 2 chloride and sodium nitrate. That would be so long for you to write out words all the time. It's kind of like, could you imagine doing math and writing out the words for the numbers all the time instead of just the symbols for the numbers? That's why we have the chemical symbols. It makes things so much easier for us to do. So let's do that same sentence in symbols. Okay, so if I substitute the chemical formulas using the symbols, here we go. We've got our lead 2 nitrate. This is the same thing. And our sodium chloride right here reacting to produce lead 2 chloride and sodium nitrate. I don't know about you, but I would much rather write this than the one on the top. Okay, here's another. I can have bromine gas and sodium chloride reacting to create chlorine gas and sodium bromide. Now, the symbols, so much easier, right? So we're going to use symbols to designate our equation. Okay, sidebar. Notice that the bromine here has groups of 2, and same with the chlorine has groups of 2. There are gases that when we have them in the elemental form, meaning that they are just the element, they aren't bonded to anything, they actually bond to themselves. These are what we call the diatomic elements. Diatomic just means 2 atoms. So the diatomic elements are such. They're bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. They all come in groups of 2. And there's a reason that I put them in this order. When we spell them out in this order, they spell the last name Brinkelhoff. And it's a lot easier for you to remember it, that the diatomic elements spell out Brinkelhoff, than for you to individually memorize them. So remember, bromine is Br2, iodine, I2, nitrogen, N2, chlorine, Cl2, hydrogen, H2, oxygen, O2, and fluorine, F2, when they are not bound to anything else. When they are elemental, they come in groups of 2. Okay? You may have noticed that the equations up top don't balance, meaning I do not have the same number of the element on both sides of the reaction arrow. Okay? So we're going to use the law of conservation of mass. Do you guys remember what that is? The law of conservation of mass states that I can neither create nor destroy matter. So that means I have to have the same number and type of each element on both sides of the reaction arrow. Okay, I'm going to go over that again. The number and type of atoms on each side of the equation or each side of the reaction arrow have to be the same. If not, I am not obeying the law of conservation of mass. Okay? So let's talk about how we properly balance equations. The only part of the equation that we can change are the coefficients. Okay, these are the numbers in front of the compounds or elements. Okay, we can only change the coefficients. We can never, ever change or add a subscript. These are the numbers after or in the middle of a compound. So, for example, if I have sugar, C6H12O6 glucose, I can put a number here. This is good. Yes, I can do this. I can change that. I can change that. This, or this, no. I cannot change those. Okay? So I can change the number out front, but I cannot change the subscripts at all. 0. Okay? So let's take a look at what this means then. So if I have 2, this is my coefficient. It means I have 2 sodium chlorides. It means I have 2 sodiums. And it also means that I have 2 chlorines. So when I figure that out, I've got to account that on the other side of the equation, I also am going to need to have 2 sodiums and 2 chlorines. Let's do another one. If I have this parenthesis is just like a parenthesis in math. We multiply everything within the parenthesis by the subscript after it. So everything in here is going to all be multiplied by 2, that subscript. So when I figure out how many calciums I have and how many nitrogens, this will give me 1 calcium. Let's see, 1 times 2 will give me 2 nitrogens, and 2 times 3, notice we're multiplying because it's a parenthesis, this gives me 6 oxygens. Okay? Okay, so that is how you read subscripts, that is how you read parentheses, and that is how you read coefficients. Okay, so let's do one where we have both. If I have 3 CaCl, that means I'm multiplying everything in this whole thing by 3. So I will have 3 calciums, and 3 times 2, that will give me 6 chlorines. So, we ready to do some of this? The best way to learn how to balance equations is to simply just try and do a few. The more practice you do, the more it will come to you. We're going to start off with some easy ones, and then we're going to build up to a bit more that will require some thinking. Okay? So I like to look at element by element. So if I look at hydrogen, I've got 2 hydrogens. I've got 2 hydrogens here. So I'm pretty okay here. I've got 1 oxygen here, and I've got 1 oxygen here. I'm okay so far. And I've got 1 carbon here, and I've got 1 carbon here. So yeah, that's balanced. If I can spell, that's balanced just the way it is. Okay, so I don't have to put any coefficients in it. Notice if I don't have a number here, a 1 is implied. Just like if in a math equation I have x plus y equals z, If I don't have a coefficient here, a 1 is implied. Okay, same thing with chemistry. All right, let's look at this next one. Now notice that this next one is made up of completely hydrogen, carbon, and oxygen. So when you see an equation that's completely made up of carbon, hydrogen, and oxygen, I want you to do it in a certain order. Do your carbons first. Once your carbons are balanced, then start working on your hydrogens. Do your hydrogens second, and then do your oxygens last. Save your oxygens for last. Okay, so let's start with our carbons. I've got 3 here. I've got 1 over here. So what can I multiply my 1 to make sure that I have 3? Is 1 times 3? 3? Yep. So now I have 3 on both sides. 8. I've got 2. What can I multiply 2 by to make it 8? Did you say 4? Yep, I can multiply it by 4. Now I'm going to look at my oxygens on this side. So 3 times 2 gives me 6. 4 times 1 gives me 4. 6 plus 4 gives me 10. Notice I have groups of 2. So 10 divided by 2 is 5. So that means I need 5 oxygens over here. And we are balanced. Okay, let's look at number 3. Rhodium. I've got 1 here, I've got 1 here. Pretty okay. I've got 3 oxygens here, I've got 1, and I've got 2 here, which is 3. This is balanced the way it is. Done. Okay, number 4. I've got 1 praseodymium, I've got 1 here. I've got 5 iodines, and I've got 2. How do I make 5s and 2s get along? I need to find my least common multiple between 2 and 5. So if you think of the least common multiple between 2 and 5, isn't it 10? So I need 10 iodines, okay? So how much do I need to multiply 5 by to get 10? What times 5 is 10? 2. And what times 2 is 10? 5. Okay, so I'm going to leave that. Notice I also multiplied my praseodymium. So I need to multiply this by 2 as well so that I have 2 on both sides. Okay, I'm done with that. All right, now let's look at this next one. See if you can give it a go by yourself. You ready to check your answer? Okay, I've got 1 potassium, 1 potassium. I'm okay. I've got 1 chlorine. I've got 1 chlorine. I've got 3 oxygens here, and I've got 2. How do I make 3 and 2 play nicely? What's my least common multiple between 2 and 3? Isn't it 6? Okay, so what do I need to multiply 3 by to get 6? Did you say 2? And what do I need to multiply 2 by to get 6? Did you say 3? So notice this now gives me 2 potassiums. So I need to multiply my potassiums by 2. And it also gives me 2 chlorines. I needed to do that too. Okay, we ready to go for that? Okay, let's try number 6. Now I'm going to save oxygens for the last. So I'm going to start with my antimonies. I've got 2 antimonies here, 2 antimonies here. We're okay. I've got 3 sulfurs here. I've got 1 sulfur here. So I'm going to multiply this by 3. Okay, so I'm going to look at my oxygens on the product side. I've got 4 oxygens here. 3 times 2 gives me 6. 4 plus 6 gives me 10, right? So 10, I need 10 over here, but it's in groups of 2. So 10 divided by 2 gives me 5. So I'm going to need 5 there. Okay, so that will balance everything out. Let's look at number 7. Aluminum, 1 aluminum, 1 aluminum. hydrogen, 1 and 2. What can I multiply 1 by to get me 2? Did you say 2? Yep. Okay, 2 chlorines. 2 times 1 is 2. Oh, I have 3s. How do I make 2s and 3s fit nicely? What's my least common multiple? 2 and 3 is 6. So what do I need to multiply 2 by to get 6? Did you say 3? Sometimes you're going to have to multiply things out. So 3 times 2 will actually give me a coefficient of 6. And then 3 times 2 will also give me 6. So I need to multiply that by 6. Or sorry, not by 3, by 2. Oh my goodness, I'm misspeaking all the time. So that means I need to go back and fix my hydrogens, doesn't it? So I have 6 hydrogens now. 2 times what gives me 6? Did you say 3? I also need to fix my aluminums. I have 2 over here now, so I need to go back and do this. So sometimes we're going to have to change our coefficients that we've already put in. So my suggestion to you would be to use a pencil for when you're first starting out and you're learning how to do this, because it's going to take you a while sometimes to get the mix. Okay, now this next one. Do you see that I've got this group of nitrate, and I've got the same group over here? It hasn't changed. And I've got this group of hydroxide, and I've got this group of hydroxide. If the groups do not change, then balance them as a group. So if you have our polyatomics, notice these are our polyatomic groups. Balance them as a group. It makes things so much easier. So much easier. Okay, so let's look at this. I've got 1 lanthanum. I've got 1 lanthanum, so I'm okay. I've got 3 nitrate groups here with this lanthanum. I've only got 1 nitrate group over here with my sodium. So I'm going to multiply this by 3 so I can get my nitrate groups to balance. Okay, so I've got 1 sodium here. I just multiplied this by 3, so I've got 3 sodiums over here. So I need to go back and multiply this by 3 to get my 3 sodiums. This gives me 3 hydroxide groups. Do you see the hydroxide groups? And I've got 3 hydroxide groups there. So that is balanced. Okay, let's look at number 9. I've got my hydroxide group, but I don't see it anywhere. But I have my phosphate group. That definitely stays the same. Okay, so let's check this out. I have barium. I've got 1 of them here. I've got 3 of them over here. So I think I need to do this. 3 times 1 gives me 3, right? And I'm going to look at my phosphate groups next. I've got 1 phosphate group here. I've got 2 here. So I need to multiply this by 2. Okay? Now, you would think that this hydrogen then would be going with this hydroxide, and you are right.